Drone racing, 4-cell versus 6-cell LiPos. What's the big deal? What's the difference? Let's find out. First of all, what is drone racing? Drone racing involves flying aircraft like this one at speeds in excess of 80 to 100 miles per hour. Pilots wear goggles to see a first-person point of view from the aircraft and use radios like this one to control them. A typical race format involves flying a course of gates and flags for 2 minutes. At the end of those 2 minutes, pilots are allowed to finish their final lap. The biggest issue, however, is finishing that 2 to 2.5 minute race. Battery technology is currently the most limiting factor in drone racing. It means that lithium polymer batteries like this one are about the only option we have. It also means that energy density must be kept relatively constant across all setups. It's forced many pilots to look for more efficient setups, often using higher voltage and lower kV motors. Sam from the future here to explain kV. It's simply the theoretical RPM of an unloaded motor per volt. This makes sense using the equation P equals IV. We can keep power relatively constant by increasing voltage and lowering amp draw. We can also see that 4-cell setups of 16.8 volts paired with 2600 kV motors yield relatively similar theoretical RPM outputs as that of a 25.2 volt 6-cell setup with 1750 kV motors. Other advantages of 6-cell include more consistency throughout the entire flight, more torque at the motors making it fly better, and also less stress in the electronics, which means less energy is lost as heat. We can compare the 1.05 amp hour 6-cell battery and the 1.55 amp hour 4-cell battery and see that they have very similar watt-hour ratings. This means they also have very similar weights, making both aircraft fly very similar for testing purposes. Before doing a more direct comparison of 4-cell versus 6-cell, I think it's important to discuss the recent Open Grove race held in California. Pay special attention to the two pilots on the right. These pilots are flying 4-cell setups. The four on the left, however, are flying 6-cell setups. Before going into a more direct comparison of 4-cell versus 6-cell, we must first discuss the recent Open Grove race held in California. This is significant because it was the first race to be held since the rule change allowing for high voltage setups. It also featured many top pilots from around the US and had a throttle-intensive course, showing some of the differences between 4-cell and 6-cell setups. This course also forced many pilots flying both 4-cell and 6-cell to overcharge their batteries. Overcharging is the unsafe practice of charging batteries past their manufacturer-recommended limits. Lithium polymer batteries should only be charged to 4.2 volts per cell. Standard overcharging charges to maybe 4.35 volts per cell or even 4.4 volts per cell. Most pilots at this race flying 6-cell charged to those limits, though some pilots like Vanover, the pilot in the top right, were even charging their 4-cell batteries up to 4.75 volts per cell. This led to one battery fire at the race and shows the advantage of the more efficient 6-cell setups. Pilots flying 4-cell had to do things like limit their power and take tighter lines. Pilots flying higher voltage 6-cell setups had a larger margin of error and could push their setups just a little bit more than those flying 4S. By the end of the race, a few things became apparent, most notably of which is the competitive edge that 6-cell provides. Pilots flying 6-cell were able to finish most of their races, while pilots flying 4-cell had to make sacrifices. Freefall on the bottom right was flying some of the most efficient 4-cell motors available. These motors are also less powerful than traditional setups, meaning that taking tighter lines is crucial. Vanover in the top right has since become more open to 6-cell setup, given his issues charging 4-cell batteries to excessive voltage. Next, let's look at a side-by-side comparison of a 4-cell and 6-cell setup. Both quads being flown here are built for a nearly ideal comparison. They both use the same exact components except for motors and batteries, and weigh about the same. Behind the sticks we have professional pilot Zachary Thayer flying consistent 19 to 20 second lap times. By the end of the flight we can use his experience and the on-screen data to get an accurate idea of the real-world differences between 4-cell and 6-cell. Let's go ahead and skip to the end of the video to hear his thoughts on the flights and look at the data recorded. Here we are at the end of both flights. First, on the main screen, we'll see the 4-cell quad land, while the 6-cell quad in the upper left is able to fly longer and complete another lap. The end-of-flight data shows us that the aircraft was armed for a total of 2 minutes and 39 seconds, pulled a maximum of 114 amps, and drew over 1600 milliamp hours from the battery. This, compared to the 6-cell quad which flew longer, pulled a maximum of 64 amps, and drew only 1070 milliamp hours from the battery, shows the increased efficiency of the 6-cell setup, given that it was able to fly longer and use a smaller percentage of its battery's capacity. Now let's hear what the pilot had to say about the flight and his thoughts on 6-cell.
But to me, it was the two most apparent parts was the full throttle punch out to the split S. It was harder to recover and hit that real flat angle you talked about, where I come down and just hit straight. That was harder. I think if you watch it, you'll see it bobbles a little more. And then the hairpin right after that through the gate, it was getting harder and harder to get up out of that corner.
This longer lasting power at the end of the battery is one of the most notable features of 6-cell quads. It's also consistent with the lower amp draw on batteries and leads to greater consistency, as Noob will discuss next.
The biggest difference, I would say, is 6S was much easier to pilot due to its consistency.
And that's something that's going to be hard to bring out as we try to make scientific testing.
Agreed.
Because you feeling more confident, people will say, well, that's subjective. Well, yeah.
Yeah, so racing, there is subject. It's a mental game on top of an equipment game.
Yeah.
So what I would say, my biggest difference here is when we did the full send with the 6S, I still felt I could go faster.
Sure.
Whereas here on the consistency with the 4S, which is not a full send, towards the end of it, I was struggling to stay consistent.
Consistency throughout the entire flight is one of the most important things to pilots, because small changes in handling near the end of the flight can lead to crashes.
When the battery sags on 4S, the biggest thing I started noticing is your tune actually gets looser. It's like you're flying
absolutely.
at 3S now.
Yeah.
With the 6S, I was able to actually still hit my lines easily due to that. And that was something that just sort of popped into my head right now is with the 6S, as your lowest voltage actually being higher relative to the lowest voltage on 4S, it feels so much more consistent. Your quad actually does, I think, fly more consistent.
And maybe the thing...
To summarize, I think that 6-cell really is the future of racing. As pilot skills continue to increase and as races become more and more competitive, we must push the limits of technology further to achieve longer flight times and more consistent flights. But how does all this relate to physics? Well, it's an exciting new application of a theory that aims to maintain power while also decreasing amp draw for the benefit of our batteries. FPV racing really is a poor man's F1, where consumers must continue to push available technology to maximize performance. I have no doubt the future of drone racing involves high voltage. It's exciting to see theories like this one paired with real-world testing that truly change the sport as we know it.